Okay, these notes are accuracy, precision, and significant digits. Okay, accuracy versus precision. Precision relates to the degree of reproducibility or uncertainty of the measurement. So there's two things for this. Reproducibility. Can you reproduce that same measurement time after time after time? And then as far as the uncertainty of the measurement, how far past the decimal can it go? If you look at maybe a sundial, okay, that is not as precise as, say, a clock, because a sundial, you're like, it looks like it's about 1 o'clock, okay? You can maybe guess the minutes, but it's not precise. So it's an hours with a guesstimate being the minutes. Then you go to a clock with the second hand. That's a little bit more precise. You can actually get the minutes and the seconds and possibly even tenths of a second, depending on what type of second hand it goes with. Well, that's fine and dandy, but that's not as precise as, say, a watch with a second hand. Then you've got the exact number of seconds, which is not as precise as maybe a stopwatch or something that can go beyond seconds to tenths of seconds or milliseconds or whatever you want to call them, but beyond that. So the more digits you can add past that decimal point, or the more digits you can add to that measurement, it makes it more precise. Okay. And then, of course, the accuracy is, how close are you? Like, let's say an apple, you've measured an apple, and each time you get 4.55 grams or 4.52 grams or 4.56 grams, very precise measurements. But if the apple weighs 6.25 grams, in reality, you're not very accurate. Okay, so accurate means how close to that true value can you get. Okay, so let's take a look at, this looks like me throwing darts, actually. Yeah, neither precise nor accurate. If this person was shooting for the bullseye, which looks like about me shooting for the bullseye, not exactly precise because they're all over the place, and you definitely didn't hit the bullseye, so not very accurate. As I said, this looks like me shooting darts. Not a good thing. Now, on this one, you've gotten all one number. It's precise but not accurate, depending on if you're shooting for the bullseye. Now, if you're playing cricket and that's the number you're shooting for, then you're both precise and accurate. But most of the time, people are shooting for the bullseye. That would be precise because all of the darts are in one spot. So you're reproducing your results each time. You're just not hitting the number you want to hit, which is the bullseye. Okay. So this is both precise and accurate. This is somebody who is very good at darts. They can hit the bullseye each time and hits it each time. So this would be both precise and accurate. Okay, let's talk about reliability, because a measurement has to be reliable, and there has to be a certain, how reliable are numbers in a measurement. So how reliable is a measurement that results from mathematical operations such as addition and multiplication? You got to take those into consideration, especially when we're doing our measurements in chemistry. So we need to know which digits are significant and which are not. In other words, which are known and which ones are we kind of estimating here? Which brings me to significant digits. Significant digits in a measurement include all the digits that can be known. So like if it's a balance, maybe 25.6 grams are for sure. And then that last digit's kind of flashing between 8 and 9 and 7 and all that. Then that's your last digit that must be estimated. So that's an estimated digit. Okay, so for example, if you read a thermometer, you can read the thermometer at 1 degree intervals. Oops, that's supposed to be 1 degree intervals. You can also estimate the temperature to the nearest 10th degree. So if you look at a thermometer, okay, and let's say, oops, that didn't work out. The red mark is, let's see, this is your 35, and this is your 36, okay? And your red line is right there, okay? So you can read it, it's above 35, but it's not quite at 36. So you can guesstimate that around 35.8, 35.9, something around there. You're not going to be wrong. If you're off by a 10th, who cares? Because that's a guesstimate. But what does matter is 35 point something. It tells the person looking at the measurement that it's above 35 and it's almost to 36. And that's the main thing with significant digits. So these would be significant figures. Okay, let's look at the rules for determining the number of sig figs. So how do you determine how many significant digits are in a measurement? Okay, and it really boils down to the zeros because all numbers 1 through 9 are significant. Okay, it's the zeros that sometimes they are, sometimes they aren't, depends on where they are. So all zeros between two numbers. So if you look at 3004, all of those, that would have 4 significant digits, or 4 sig figs, because the zeros are significant, okay? So let's say we have another number. Let's do 10509. Once again, these zeros are in between. So that is 1, 2, 3, 4. That's 5 sig figs, okay? It's when they're in the beginning or the end that they become placeholders, depending on whether there's a decimal or not. Everything depends on the decimal. So if the number has a decimal point, so you got to look for a decimal, then all of the zeros at the end are significant, not in the beginning, because in the beginning they're just placeholders, but at the end they're significant. So if we look at this one, example 1, there are, oops, hang on a second, didn't mean to do that. There are 3 sig figs, okay? Now if you look at here, remember, zeros at the beginning aren't, so there's only 1 there. And then here, we're going to ignore the ones in the beginning, and there's 2 there. Now, there's a little rule of thumb, and that is you're going to find the first number and count right, but you include that number. So let me show you how that works with this. I'm going to erase this so you can see it. So it's a little trick that I've learned, and it makes it so much easier. That way you don't have to memorize the rules so much. Just know if there's a decimal, first number, count right. So here we're going to go 1, 2, 3. Okay, 1, 2, 3. So there's 3 there. Here, our first number is here. There's nothing to the right, so it's just 1. Here, our first number is the 3, so we're going to count to the right, and there's just 2. It does make it a whole lot easier when you do it that way. Okay, if there's not a decimal point, then zeros at the end do not count. So we're just using the first 2 rules. Okay, so if we look at this one, this has got 3. Now here, if you look at 30040, that last one doesn't count, making it 4. Here, the last 3 don't count, so this has 1. Now, if this was 3000 with a decimal point, then this would have 4. But without that decimal point, you're saying it's about a 3,000. Not 3,000 exactly, but about 3,000 people or 3,000 whatever. So all of these numbers, when there isn't a decimal point, like look at 30,040. That's about 30,040. Could be 41, 42. We don't know. We're just saying about 30,040. So that last zero doesn't really count. Okay. Okay. So there's a rule of thumb with this one. And I didn't type it out, so I'll write it down. So rule of thumb, you're going to find the last number, not the first one, the last number. Now remember, zeros are not numbers. Zeros are placeholders only. They do not have a value in science. They just hold the place. That's all they're considered placeholders. So numbers are only 1 through 9. So you're going to find the last number, in other words, the last digit that's 1 through 9, and count left. Not right, count left. So you're basically doing the opposite of what you do with a decimal point. So let me show you with these. So we're going to erase all this. So, okay. So if you look at the first one, the last number is the 4. And we're going to go 1, 2, 3. So there's 3 numbers. Remember, you also have to count that last one. So here, we're going to, this is the last number. So we can cross that off. We go 1, 2, 3, 4. Same with this one. This is your last number. It's your first number, but it's also your last number. And there's nothing in front of it, so there's just 1. So sometimes it makes it easier to use the 2 rule of thumbs. Remember, decimal point, find the first number and count right. No decimal point, you find the last number and count left. Okay, now let's talk about scientific notation. With significant digits, and scientific notation is something that you're going to be using a lot of in this class. So scientific notation is something like maybe 1.95 times 10 to the negative 3 meters. Okay, that number is written in scientific notation. But we also have to follow rules of significant digits with the scientific notation. Now, the good thing about scientific notation, it takes out all of the unsignificant digits. So your number here will always have the proper number of sig figs. Like this one has 3. Okay, so 1.95 times 10 to the negative third has 3 significant digits, significant figures. So actually, what I like about scientific notation is if you have a number, and let's say you had to round to 2 sig figs, but the number was huge. So for example, if you had something like 10500 and you wanted 2 sig figs, well, there's 3 in this number, but you can actually write it. Now, we're going to learn how to write scientific notation in the next video, in the next section, but I'm just showing you an example. You can actually write this with 2 sig figs. Oops, sorry. Hang on. Would be 1.1 times 10 to the 1, 2, 3, 4. Okay, and there's your 2 sig figs. I'll go into more detail with that with the next video, but the main thing is you've got to be able to identify the number of sig figs in the scientific notation. Well, it's whatever's the number is. The times 10 doesn't count at all. So here's another example. So let's say we had 5.0030 times 10 to the 19th. Okay, your significant digits are located in this number and this number alone. And this one follows all of the rules. So every single number in that, you don't even have to worry about the rules anymore. Every single number, including all of the zeros in that particular number, provided it's in scientific notation, which we'll go into more detail next time, but is significant. So this is 1, 2, 3, 1, 2, 3, 4, 5. So this one has 5 sig figs. Okay. So this always is all of the numbers in that number are significant. And it does follow the rules. If you look, numbers in between and then numbers at the end. Significant digits, I mean, scientific notation, you are not going to find anything written like 0.95 times 10 to the second is not in scientific notation. So the rules don't apply. It has to be in scientific notation, which, as I said, we'll go into more detail in your next lesson. But for now, just know if the number is in scientific notation, which means there's a number first and then point something times 10 to the something, the number itself is always significant. Okay, now let's look at multiplying and dividing, addition and subtraction, mathematical operations, basically. So when doing any kind of mathematical operation, not just multiplying or dividing, your answer can only have the same number of sig figs as your least precise measurement. Now, addition and subtraction, the rules are a little different, but it's still the same thing, okay? Because I'll talk about that when we get to addition and subtraction, but especially multiplying and dividing, okay? So you have to actually count the number of sig figs in each measurement before you do the multiplying and dividing, and that way you'll know how many significant digits your answer must have. So if we look at the first one, okay, we got 1.1 centimeters. Well, there are 2 sig figs here. And then this one, we're multiplying it by 12.78 centimeters, but there's 4 sig figs here. So your answer is only going to have 2 sig figs. Now, when you put this into the calculator, you're going to get a bigger number. In fact, you get 14.058. Well, if you put that on your test, I'm going to mark it wrong. I'm going to take off a point for sig figs because that is not the answer. You can't do that. Your machine, both your instruments, neither one of them gave you 5 sig figs. So that cannot be. So your answer has to have 2 significant digits. So that would be right here. Now, You do have to worry about rounding. So once again, I don't know if you guys remember how to round, but you take the number, the last number that you have, and then, which is, like here's 2 sig figs, you look past, you go to the next one. That tells you whether you have to round up or down. So with the 4, we're going to look at the 0. That 0 tells me I don't have to round. If that was a 5 or higher, I would have to round it. So my answer is 14 centimeter squared. And you'll learn pretty soon that centimeters times centimeters is centimeters squared. Okay, so let's look at the next one. So we have 12.78 meters squared, which has 4 sig figs, divided by 5.60 meters, and that has 3. Okay, so our answer is only going to have 3 significant digits. Well, when we do the actual calculation, we get 2.28214. So I'm going to find 3 sig figs. I like to box it sometimes. Now, if you're, I'm so used to doing this, I look at the calculator, I can tell, but to show you guys, sometimes it helps to just box the 3 that you want. So you find, remember, you find the first number and count right, but you're going to count right to get to 3. Now we're going to look at the 2, and that tells me that I don't have to round up. So my answer is 2.28 meters. Now, meters squared divided by meters is meters. I'm not super worried about you guys getting the units correct at this point in time, but just the number. So the number of sig figs has to be correct. Okay, let's do one more. It's not written on here, so I'm going to have to actually move the slide up a little bit. Okay, so let's try one where we're going to have to round. So we do 13.95. I'm not going to use units this time. Times 1.7. When we do this calculation, we get 23.715. Okay, let's look at the sig figs. This one has 4 and this one has 2. So our number can only have 2. So there's our 23, but this 7 tells me, oops, I better round up. So my answer is 24. I'm not, as I said, I'm not worried about units right now, just learning the sig figs. So this is one time when I have to round up. Okay, so when adding or subtracting, your answer can only have the same number of digits past the decimal as your measurement with the least number of digits past the decimal. And that's because you're looking at your instrument. So if we look at 1.9 millimeters, we measured something that's 1.9 millimeters. Let's say you had a ruler and that's as far as you could get. But really, if you had a more precise ruler, you could have measured beyond those digits. Okay, so we don't know. It's 1.9 something, 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 something. We don't know what it is. Same with 48.07. If we used a ruler with more precise, that was more precise, then we would be able to get more digits. So your answer can only go to the 10th place because that's as far as that one particular ruler could get to. And in fact, the easiest way of doing this to see how far your answer can have, if you do it, if you write them all down in a column, okay, like this. So your decimal points are the same. And you're going to see that here is where you're actually adding 3 numbers together. Whereas the next one, you're just adding 2. And then the following ones, you've got 1 number each. So it basically just kind of falls to the ground or falls back down. So when we add this up, okay, we get, and yes, I'm doing this by hand. 16, 17, 18. So put it there. Put the one up there. So it's 14. Put the one up there. And you can do this on the calculator. And this is the answer you would get. So what we're concerned about is right here. Okay. This is our answer. 104. So it's 104.8 point. Now, the 3 we have to look to here. So that 3 tells me I don't have to round. So 0.3 millimeters. Okay. And that's it. So you don't have to worry about like one has only 2 significant digits. Your answer doesn't have to have 2 significant digits. as I said, when you're adding and subtracting, we just worry about the places past the decimal. So let's do the next one. So if we subtract, and we can line them up, 64.7 minus 23 minus, and now this one is 0.025. Okay, if we look at this one, there's nothing past the decimal. So we're still going to do the subtraction, but our answer is not going to have any places past the decimal. So when we do the subtraction on this one, we get 41.675. And I'm not going to worry about doing this by hand. You just do it on the calculator, and this is what you get. So this is the number, but then here it tells us we have to round. So our answer is 42 grams. Hopefully that makes sense on that one. Okay, so now we're talking about calculations involving multiple steps. So when calculations involve multiple steps, the number of significant figures in subsequent, which means later steps, requires us to know the number of significant figures in the answers from the previous steps. In other words, you got to keep track. That's all it is. You have to keep track of the numbers. I do it by underlining. You can do it however you want, but I think underlining is probably the easiest way. Okay, let's look at this example. So we have the first, now if you remember your, I guess the order of operations, okay, it's PEMDAS. Parentheses first, then exponents, multiplication, division, addition, and subtraction. So we have a set of parentheses that we're going to do first. So when we do the actual addition, and once again, I'm going to show you the long way to do it. So we got 12.26 minus 10.1. Okay. So we're going to take it and we get 6, 1, 2, and that's it. But now, once again, like I was doing before, this is where our answer, but we have another step to do. So if we were to just stop here, my answer would be 22, but we don't want to stop here. We have another step to do. So we can't round yet. So I'm going to say do not round yet. Okay. You don't want to round yet. What you want to do is underline or box or whatever you want to do your significant digits. So here, this is the number that should have been. So if this was the answer, if we weren't going further, it would be, as I said, 2.2. But we're going to use the 2.1. So now we've got to do the division. So I'm going to take that 2.16. Now, I like to not underline both. Some people, I've had a professor a long time ago, she just underlined the 1. I don't like to do that. I like to do the whole number. It just helps me. Whatever you want to do, as long as you can keep track that there are only 2 significant digits that you can use as far as the answer goes. Then we're going to take the division. We're going to divide it by 2.45. And when we do that, we get the answer is 0.8816, blah, 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 blah. It goes even further. So here, now we have to figure out how many significant digits. So 2.16 normally has 3, but if you recall, I only have 2. So there's 2 sig figs here. Then there's 3 sig figs here. My answer can only have 2. So, and then this tells me whether to round or not. So my answer is 0.88. Okay. Hopefully that helps. Now let's try one more. Let's try one that's a little bit harder even. So let me move this up. Okay, let's try another one. Well, let's try, we have 1.35 plus 12.6 divided by 5.0 plus 19. Now, order of operations, we have to do the parentheses first. Okay, so when we do 1.35 plus 12.6, we get 13.95. Now, as I said, once again, we have to make sure we keep track of our sig figs. So this one would have 1 place past the decimal. So we're going to say this is the significant part of this digit. So now we're going to take that number, so 13.95, 0.95. We have to put them both there. Divided by 5.0, but I am going to underline that, gives us 2.79 is the answer to that. Now, this has 3 sig figs, and this has 2 sig figs. So I need to underline that. Now remember, we're still not rounding. So we didn't round the first time. We're not rounding this time. We don't round until after we add that last step. And when we do this, we get 21.79. So this 2 sig figs, now actually 1 place past the decimal, no places past the decimal. And you could have, just to figure it out, you would have done 2.79 plus 19 gives me the 21.79 going down here. Let me move this up a little bit. Okay. So this tells me to round. So my answer is actually 22 on this one. Okay. Hopefully that helps. Hopefully you understand all this. When we get into class tomorrow, we'll do a warm-up. So we'll do a few examples of all these just to make sure you know what you're doing. Make sure you have your notes with you. Okay. And if you have any questions, tomorrow's when to ask. See you later. Bye.